Okay, continuing with the part two of the SageMaker fingers dataset classification. In the previous video, I talked about how I divide the dataset, but let's check again where is the dataset on Kaggle. So in Kaggle, you can find here the dataset. Obviously, you have to log in, sign in to download all the dataset. But practically, the dataset contains 200, sorry, 21,000 or more image, about 128 by 128. This is the original dataset. 18,000 images of the training set, 3.6 thousand images of test set. But as, as I told you in the previous video, I make some arrangements to divide the training set in validation too. So here we're importing all the libraries that we are using to make this thing. One important thing I'm not telling you is that, for example, in the next video, we will doing training in SageMaker, but the way that we use SageMaker is, or if we are using a custom script that I'm trying to do, is to prepare a Python script. And this notebook helps me a little bit to get less flaws on the deployment and the training, hyperparameter tuning, and deployment process. So the first thing I recommend always is to make a custom notebook for the functions that will be used in the hyperparameterization, sorry, on the hyperparameter tuning and the training sets. So the first thing that you are trying to see if you have a CUDA enabled device. Obviously, in my case, I have a NVIDIA, I think GTX 1650, and we are preparing the dataset to ingest to our neural network. So the first thing is to, because we're working with image, there are some prepared functions on PyTorch that we can use. I'm not a power user of PyTorch. I'm more like a TensorFlow guy, but mm, eh, in these days you have to know so much frameworks a part of the one that you handle. So that's why I made this one in PyTorch. So to ingest the information on the neural network is a better way to do so doing custom data loaders. So the custom data loader practically is our image folder or where are the source files that we're using. For example, we have a train data loader here. So here we are using the training set, the validation set, and the test set. We are doing transforms specific for that image folder. And finally, we are loading the tensors on the train loader. So for the, if you see the train loader, test and validation loader are the same. They are not different. So you have to start using a pipeline like this. One thing you will note is that I put here grayscale, but the number of output channels is 3. Well, that's because I was a little bit lazy, and I'm below you will see that I'm using a protein neural network based on VG16. So VG16 is training on color image. That's why even if I convert to grayscale, I prefer the number of channels to be 3 to keep the same alignment of channels and not do uh, funny stuff before feeding on the neural network. The next thing I did was to test the data to see when we load the loaders over the batch size, 32 and the finger sorted folder, that we get the three channels by 108 by 108 based on the batch size of 32. So this gives me the feedback that I wanted to know, that currently I'm doing well my custom data loader. Next, we will be using transfer learning to train our neural network. So the first thing, and this is based on PyTorch 1 point something, it's not the last version of PyTorch that I have here instantiated, is that we are using the neural network model. So the first thing we will do is to load the model VGG16 with the ImageNet wakes. That kind of line you can preserve, but I actually disable. You can enable if you wanted. I did some results, and the results, experiments, and the results were the same. So this doesn't matter for me. Another thing to do is to just only keep the bottleneck uh, for fixing the parameters and holding the others frozen. And this part one is the bottleneck that we will be using. We're using a linear function to then apply an activation layer of ReLU, making dropout, linear dropout, and in the end, the output will be the number of classes. So one thing to note here is that you have to be careful on the input image, and also the I think this parameter is about um, filters and the kernels. So you have to keep everything in the same dimension between convolution. For example, here you will see that this one is the same as this one, and this one is the same as this one, just to keep the convolutions working correctly. And finally, you implement a forward pass to the class here. Finally, we instantiate the neural network. As you see here, we have 12 classes. That's because we have 10 fingers, but we are counting also the null. So that's why null fingers. That's why I have 12 cases. Obviously, if you are using CUDA, you have to pass or tell PyTorch which device you will be using to make the computations of the neural network. Here you can see the neural network. All those things is from VG16. You can do it manually, but if you can instantiate a new pretend neural network with some ways, I prefer to do that because it speeds up my training. Finally, after that, you got an adaptive average pooling. And finally, here the bottleneck is the classifier that we did. We did a linear, then dropout, then linear, then dropout. So this is this thing here. Finally, we got to the part that we had to make to train the model. Here is the training function. You will load the train loader, the validation loader, also criterion optimizers, and which device you are doing the computations. And the first parameter is the model. So for each epoch, depending of you are on training or validation, you will be running those steps and try to minimize the loss. And if we are doing training sets, and if we are doing the training part, you will be running here. Each time you will print an output giving 20 runs of over the epoch. So if you want to train over a full data set, you have to comment this line. I put this here. If you want to train over the whole data set, you have to disable this or so, uh, have it apart. And if you're on the validation set, you keep just looking for the metrics here. So that's the training part function. And the test part is pretty simple because we on the test loader you get the inputs and labels, calculate the model predictions here, make uh, calculations of the loss, also calculating the output predictions and measuring how much are true positives and true negatives and summing over the total of the dataset to get the accuracy. So you print the accuracy of the model and the loss of the model. For using it, you have to instantiate also the cross entropy loss. Remember that we are using a multi-class classification, so we need in the cross entropy loss as a criterion, and the optimizer in that case I'm using stochastic gradient descent with a learning rate of 0.001 or 0.01. Sorry. Here now we train our model with the parameters that we specified above, and you will see that I didn't need too much to get good results over the training set. So that's why I put these lines here to not train over the whole data set. That will be unnecessary in my case. In your case, probably if you are using another data set, you will have to train over the whole data set running different epochs. I only run probably once, two epochs here. And that's enough to achieve 98% of the accuracy. So I test the model, I get practically the same test accuracy. I get 98 on the training set, 97.5 on the test set. The loss is kind of low. And finally, I save the model using the function over the tar file. So I tar the model here just to keep it simple for me. And now comes the tricky part here. Remember that I told you that you're doing classification of images using SageMaker here. Even this apply with any kind of modeling. It doesn't matter if it's classification, regression, or time series analysis, or you're training again, or an anomaly detection. When you start using SageMaker and you try to predict something, the first thing that is called is the model function. The model function will load the model. The input function is not necessary at all, but if you use it, you will input the the data here, and you will transform to some kind of structure that you can process on the predict function. And finally, when you get out of the predict function, you can post-process your results and output a valid JSON format, for example, and present to the user. Or, for example, if you are using a Lambda microservice, you usually probably you will only need to predict over the class only. You probably want to get a message, also the probabilities, something that the default functions that will not ensure, you can ensure with all those things. So for the first thing, the modeling function is pretty simple. You get the model there, call the model, try to predict over the model. Sorry, try to extract and get the model as a result. This is also needed the when you are trying to doing uh, sorry, when you're trying to doing the deployment. So that's not necessary for the training, but for the deployment is mandatory. Next, the input function. You have the request body, usually are byte arrays. That's why you will see that on the function I will be using the IO library. And the request content type, there are different kind of request content type. I use application PNG, specifying that I will be using just only PNG image. But let me show you what is the request content type. Let me see if I can find it. Request content type, SageMaker. Common data formats. Okay, let me see here. So if you check here on the reference on SageMaker, you have any kind of common formats here for the content type that can be, for example, X record IO. So you can have record IO text CSV that will be the recommended split type to be line, the application JSON lines, application JSON, Ximage, image, any kind of image type. That's why I use PNG. You can use uh, image image slash star if you want, but I prefer to use this one, image application PNG. And the return image type will be this one. You will see that if the input is byte array, we have to convert this byte array and open it. If everything is okay, then we'll return this. If not, if it's another kind of file that is not handled by the function, it will return that can only process image that are PNGs. Next, because we are outputting the image, comes here to the predict function that will be the input OGL model. We have to pre-process everything. Remember that we did that on the previous step, so we need to pre-process it. Because we are doing image by image, we'll be doing expansion of the tensor and predict the results over here. Obviously, in SageMaker, you can handle so much predictions, but I'm doing that in that way. And the output function, I will be trying to put it on a dictionary. So here I have these classes for all the fingers, the 10 fingers and the 2 null fingers. And we make predictions over the CPU doing NumPy, transforming into NumPy, sorry, and looking for the classes over this array. Finally, we sort the values and flip the predictions. You will see if you do it manually to, in the end, expose over JSON dictionary that will be transferring as an output. So here we are specifying what is the test folder. We use a random choice of these things because the test folder has all those labels of folders. So I will be doing a random choice and opening an image. In that case, just I had been lucky to open this image, and we are doing the first thing. Look at this here. We first load the model over here. Next, the input function. Now the predict function that give me the results of the tensor, and the output function give me classes and predictions. Normally, I think the output are about predictions, but I specify not only predictions but classes too. And the last thing I did was to put an image with the ground truth and the predictions of the model. So here we have a high five. But that's practically what we do before making hyperparameter tuning and training, and finally deployment on SageMaker. We did some basic notebook with a clear explanation and also trying to emulate the deployment here that will give us a quick reference on how to make the .py model, sorry, the .py file to uh, try to deploy later. So that's all. On the last, on the next video, I will at last and finally explaining how to do all the complex stuff in SageMaker. So keep looking and try to test this for your understanding. That will help you a lot to understand how SageMaker operates. And we will see you on the next video. Thanks.